Hello, dear student. Welcome back in our topic heterocyclic compound. Myself Arif Khan, senior lecturer, MC Society Institute of Pharmacy. So, nomenclature we were discussing some of actually two rules we already discussed. The name of five-membered heterocyclic ring containing two double bonds ends with OLE. For example, this is the five-membered ring containing two double bond and one heteroatom. So, from that accordingly, it is a pyrrole. Next, imidazole, which has a five-membered ring containing two double bonds, so obviously it will be ends with OLE, and imida stands for two nitrogen at relative position 1 and 3. Next, if one double bond is there, five-membered ring, but only one double bond, then E of OLE is being replaced with INE. So in this we will take the example imidazole become imidazoline, and with this also we have to show the position of double bond also. You see that the numbering is already specified, and that is we have to start the from any of the nitrogen, because both are saturated nitrogens. So from any of nitrogen we can start a numbering, and the second nitrogen will get the third position. Accordingly we have to give the numbering so that the double bond will lies between the 4 and 5, and we are showing that the first position of double bond, that is 4, so it will be 4 imidazoline. Next, now actually it is a 2 imidazoline, because there are two nitrogen, one is saturated, second one is unsaturated, means double bonded nitrogens. So in this case we have to start the numbering with a saturated nitrogen, and the next nitrogen will get the third position. So in this case this will be the way of numbering, and the double bond lies between 2 and 3, so we'll take 2 as a position of double bond, so it become 2 imidazoline. Basically it is derived from imidazole, but instead of two double bond, only one double bond is there, and we have to specify the position of double bond also, and due to presence of only one double bond, E of this imidazole is being replaced with INE, it become imidazoline. And not only imidazoline, it become 2 imidazoline. Next rule. Now if there is no double bond, five-membered ring, but there is no double bond, so what is the changes in the name? E of this OLE is now replaced with IDNE. Example, imidazolidine. For example, this is the five-membered ring. So, and if there will be two double bond, it become imidazole. Instead of that two double bond, only one double bond, imidazoline. And if there is no double bond, in that case, what you have to change the name in the imidazole. E of imidazole have to be replaced with INE. E of OLE of imidazole is replaced with IDNE. So imidazole become imidazolidine. IDNE. E got replaced with IDNE. So this is the way. And the numbering if we are talking about, so from either of nitrogen we can start, because both are saturated, and second nitrogen will get the third position. So this is the third rule. Now next, the six-membered ring containing three double bonds, that will be ends with INE. Normally we have an example, pyridine, pyrimidine. These are the example. Pyridine, it's a six-membered ring and one nitrogen containing. This is the way, and as far as numbering is there, so we have to start numbering with the heteroatom, simple heterocyclic ring, heteroatom, either clockwise or anti-clockwise. Both are the correct way of numbering. Next example of these six-membered ring which ends with INE, that is pyrimidine. It's a pyrimidine. It's a six-membered ring, two nitrogen, and relative position of nitrogens are 1 and 3. So this is called as pyrimidine. And in this case we have to start either of from nitrogen, because both are equivalent nitrogens in this ring, simple heterocyclic ring. So either we can start with this nitrogen or with this nitrogen. Say we had started from these 1 2 3, so second nitrogen getting third position. If we are starting, means we are giving anti-clockwise way of numbering. If we are starting with this nitrogen, it will become 1, so we have to go by clockwise way, so that the next nitrogen will get the least number, third position will achieve by the next nitrogen. So 1 2 3. So this will be the way of numbering to this, and it proves that normally it ends with INE. Now name these heterocyclic rings name can be obtained by prefix heteroatoms. For example, the heteroatom is nitrogen, then it will be aza, azo, pyr. Normally P by R for first or more than two nitrogens are there or only one nitrogens are there, P by R this term comes. Or for first nitrogen or only one nitrogen. And if there is more nitrogen, maybe Pyra Aza both or Aza Azo both will comes. So wherever nitrogen, these prefix will be there in case of name, like pyridine, Pyr will be there. It means nitrogen is there. Okay. Next, sulfur. When the simple heterocyclic ring or any of the heterocyclic ring which has the sulfur, so the name of the ring prefix will be thia or thio. Thia thio comes, it means that there will be a sulfur. Next, oxa. Oxa is for oxygen, because these types of these are the common heteroatoms present in the heterocyclic rings. So wherever nitrogen, aza, azo, wherever sulfur, thia, thio, or wherever the oxygen, it will be oxa. For example, we'll take this thiazole. Thiazole stand for what? Thia means sulfur, aza, aza stand for nitrogen, and OLE stand for it's a 5-membered ring containing 2 double bonds. So by this way these can be derived. Next, oxazole. Oxa stand for oxygen, aza stand for nitrogen, and OLE, it ends with OLE means it's a 5-membered ring containing 2 double bonds. So it will be oxazole. Like this, the namings can be given to the heterocyclic rings. Next, now we are moving towards the different types of heterocyclic ring, possible different type of heterocyclic rings and their way of numbering. So in this first we have to start with the 3-membered ring, aziridine. Aziridine, it's a 3-membered ring and which has a nitrogen as a heteroatom, and there is no double bond. So as per the numbering scheme, we have to start with heteroatom, and either we can go by clockwise or anti-clockwise. So this is the way of numbering to this simple heterocyclic ring, which is a 3-membered ring called as aziridine. Example, mitomycin. Example of the drug which has this aziridine ring is the mitomycin. Next, beta-lactam. So beta-lactam is a 4-membered ring. You can see that it's a 4-membered ring, and we have to start in this nitrogen is a heteroatom. So we have to start the numbering with a nitrogen, and we have to go by this anti-clockwise way of numbering so that this carbon is substituted one. That's why 1 obviously with the heteroatom, 1, 2, 3, 4, and it's a 4-membered ring that is called as beta-lactam. And normally this beta-lactam ring is present in penicillins and cephalosporin. These are the popular antibiotics, and these antibiotics contains this beta-lactam ring. Next, thiophene. So this is the thiophene, which is actually a 5-membered ring and sulfur as a heteroatom containing 2 double bonds. So normally we have to start with sulfur. Clockwise, anti-clockwise we can proceed. Cephalothene is the name of antibiotic which has the thiophene ring in its structure, and that's why thiophene ring containing drug will be the cephalothene, which is again a cephalosporin type of antibiotic. Next, furan. Furan, this is the 5-membered ring and oxygen as a heteroatom. 2 double bonds are there, oxygen as a heteroatom. Furosemide, which is a diuretic, and nitrofurantoin, which is actually the antiseptic, particularly urinary antiseptics. So these drugs have furan as a heterocyclic ring in their structure. So as far as the numbering is there, we must have to start the numbering with the nitrogen, and we have to proceed by either clockwise or anti-clockwise. Next, pyrrole. You can see that it's a 5-membered ring, 2 double bonds and 1 heteroatom. Pyr stand for the nitrogen, OLE stand for the 5-membered ring containing 2 double bonds. So as per the rule, simple heterocyclic ring, obviously we should have to start the numbering with the nitrogen. This is one, and clockwise or anti-clockwise both will be the correct way of numbering. Last numbering will go the 5 because it's a 5-membered ring. Example, viprinium is the example which has a pyrrole ring in its structure. Next, pyrrolidine. So now in this case, if we are comparing these two structures, so we will follow the rule of giving naming, that the pyrrole become pyrrolidine means E of this pyrrole, it get replaced with IDNE. And when it is occur, if there is no double bond, if there is no double bond in the 5-membered ring, so E of these 5-membered ring got replaced with IDNE, so pyrrole become pyrrolidine. Pyrrole become IDNE comes instead of E, so that is the pyrrole. And obviously it is a completely saturated one, there is no double bond. If there is unsaturation, means presence of double bond. If there is no double bond, completely saturated. Example, ethosuximide. This is actually the anticonvulsant drug. Epilepsy, in the treatment of epilepsy it may be used. Most popular, ethosuximide, and which has these pyrrolidine in their structure. This is the drug which has this heterocyclic ring in its chemical structure. Next, pyrazole. Pyrazole stand for, it is actually the 5-membered ring. Name itself indicating its end with OLE, means the 5-membered ring containing 2 double bond. Now we have to specify that pyra and aza. PYR stand for first nitrogen, aza stand for second nitrogen. So normally an OLE stand for, it's a 5-membered ring containing 2 double bonds. So this is the structure of this pyrazole, in which there are 2 nitrogens, one is unsaturated, second one is saturated. So obviously we should have to start numbering with the saturated nitrogen, and the next nitrogen is getting second position. So we can say that in case of pyrazole, there are 2 nitrogen and the relative position of nitrogen is 1 and 2. It OLE, it's a 5-membered ring containing 2 double bond. Sulfafenazole, it is an example of the drug sulfonamide, which is an antibacterial drug which has pyrazole ring in its structure. Next, pyrazoline. Pyrazole, we know, just previous we had seen a 5-membered ring containing 2 double bonds and 2 nitrogen at relative position 1 and 2. Pyrazole. So now pyrazole become pyrazoline. So E is being replaced with INE. It indicates that there is only one double bond. In the pyrazole, there is only one double bond. It become pyrazoline. And obviously, if the double bond lies between 3 and 4 position, it become 3-pyrazoline, because we have to specify the position of double bond also. So it got clear that it derived from pyrazole. And what are the changes? Instead of 2 double bond, there is only one double bond. So E is being replaced with INE. Pyrazole become pyrazoline, and plus the position of double bond, because only one double bond if it is there, we have to specify the position of double bond. If it is between 3 and 4, then we have to specify as a 3-pyrazoline. Next, analgin. It is an example of the drug which is analgesic, which has pyrazoline, particularly 3-pyrazoline in its structure. Next, pyrazolidine. Now again we had done the change there, that pyrazole, only one double bond, pyrazoline. If there is no double bond and pyrazole, there is no double bond, it become pyrazolidine. E of pyrazole got replaced with IDNE. IDNE means there is no double bond, and obviously it is derived from pyrazole, because in pyrazole there are 2 nitrogen, relative position 1 and 2. Here again 1 and 2, relative position will be 1 and 2, but there is no double bond, so that it become pyrazolidine. Phenylbutazone, it is an analgesic which has this pyrazolidine ring in its structure. Next, imidazole. Imidazole means we had seen that the 5-membered ring containing 2 double bond and the 2 nitrogen relative position 1 and 2, it become pyrazole. And same, but instead of that, relative position it is getting to be changed. It become 1 and 3, it become imidazole. If the 5-membered ring containing 2 double bond, relative position of these 2 nitrogens will be 1 and 2, it become pyrazole. If the relative position is 1 and 3, it become imidazole. This is the basic difference and the clue to get identify or to learn or to remember the difference, as well as the difference between these 2 rings, pyrazole as well as imidazole. Next, so for this imidazole, numbering will be from nitrogen obviously, and the next nitrogen will get the list number. Saturated, from saturated nitrogen we have to start a numbering, and next we proceed that the next nitrogen will get the third position, relative position will be 1 and 3, and last will be go to 5. Numbering will be proceed till 5 1. Imidazole, the example is metronidazole. Metronidazole, it is an antiamoebic drug which has this imidazole ring in its structure. So it is sufficient for this part. Next heterocyclic ring with its numbering and the example of the drug which has this heterocyclic ring we'll see next time. Thank you so much.